So for the next example, we'll use source transformation to solve the current I/O. So using source transformation to simplify the circuit, so we have this current source in parallel with this impedance. So this can be transformed into our V is equal to 12 angle 90 times 4 minus J3 is equal to 60 angle of 3.13. Then we can further simplify the circuit. We can transform again this circuit into this voltage source in series with this impedance into a current source in parallel with this impedance. So we'll have our I is equal to V over 6 minus J2 is equal to 9.487 angle of 71.565. Now using CDT we can now solve for IO. IO is equivalent to 1 over 1 minus J2. So the admittance of this branch all over the sum of the admittance times I. Our IO is equal to 9.864 angle of 29.462. For the last example, we have the Thevenin and Norton equivalent circuits. So for this circuit, we need to find the Thevenin equivalent circuit at terminals AB. So first, let's solve for the open circuit voltage or the VTH. So we can solve this circuit. We can solve the VTH using any technique. So we'll use nodal analysis. So let's label this node as V and this node as VTH. This is our reference node. So KCL at node V, we have V over 4 minus J2 plus V minus VTH over 8 plus J4 plus 5 angle 0 plus 2, 0. So multiplying this equation by the two denominators, we have V times 8 plus J4 2 plus 2, 0. Simplifying the equation, we have our equation number 1. Now for the second equation, we apply KCL at the node VTH. So VTH minus V over 8 plus J4 minus 5 angle 0 minus 0.2 VO equals to 0. Now looking at the circuit, VO just equal to V minus VTH. So this is just V minus VTH. Now multiplying the equation by 8 plus J4, we have simplifying the equation. Uh, now we have our equation number 2. So two equations, two unknowns. We can now solve for the value of VTH. And VTH is equivalent to or delta TH over delta, where our delta is the determinant of, so this is equivalent to 17.6 plus J 16.8. Now for our delta TH, we have, this is equivalent to negative 80 plus J 160. Now our VTH is equal to 7.35 angle of 72.90 degrees volts. Now to solve for ZTH, we inject a voltage source at terminals A, B. Let's label this source as VS, and then we have a current I. Our ZTH equal to VS over I. And then we need to turn off this uh, current source. So this is turned off. This is an open circuit. Then let's label a current flowing through this branch as IO. So by Ohm's law, if this is Vs across these terminals AB, by Ohm's law, for Vs is equivalent to negative IO times the series combination of these impedances. So we have IO times 12 plus G2. For our IO, negative Vs over 12 plus G2. Now applying KCL at this node, or say node A, KCL node A, we have I plus IO plus 0.2 VO equal to 0, or VO by Ohm's law is equivalent to IO times this impedance 8 plus J4. So VO is equivalent to 8 plus J4 times IO. So we have I plus IO plus 0.2 IO 8 plus J4 equal to 0. Or we can express IO in terms of I equal to negative I over 2.6 plus J 0.8. Now substituting this equation to this equation, so we have I over 2.6 plus J0.8 equal to Vs over 12 plus J2. So getting the expression Vs over I is our GTH just equal to 4.47 with angle of negative 7.64 degrees ohms. We have our GTH.